Hi, welcome to two variable systems. Now remember that a system of equations is where you have two equations with two unknowns and you're solving, right? You're trying to find out what x and y are. And the solution to a two variable system is where the equations intersect. So you can have three types of answers. You can have one solution because they intersect once. You can have no solution because they're parallel and they never meet. Or you can have all real numbers as an answer because you actually have the same line. Now, this is kind of a review, so you should have seen this before, but we're going to go through the process of elimination and substitution. So one example of each, and I have step-by-step guide for how to do it. First, for elimination, we're going to eliminate a variable. So you come over here to your equation, and you pick a letter that you want to get rid of. Well, let's get rid of the m. Okay, we have 2m at the top and 3m at the bottom. The only way to get rid of it is to have the same coefficient, but opposite on one of them. They're not the same coefficient, so we need to make them the same. The least common multiple of 2 and 3 is 6. So we're going to multiply the top by 3. And the bottom, because we want it to be an opposite, we're going to multiply by a negative 2. And remember, whenever you do this, you're multiplying the entire equation by these numbers. So we want to come over here and write our new equation. 2 times 3 is 6, so we have 6m. 4 times 3 is 12, so we have 12n, equals 3 times 4 is also 12, but there's a negative, so negative 12. Now we multiply the bottom. So 3 times negative 2 is negative 6m. Negative 2 times 5 is negative 10n. And that equals negative 2 times negative 3, which is 6. So now we're able to eliminate that m because they're the same coefficient but opposites. Okay, so now you should see why we have to make them the same. Okay, so these will cancel. And we're left with 2n equaling negative 6. Divide by 2, and we've solved for our variable. So that was step 2, solve for the other variable. Now step 3 is to plug the number into either original equation. So you're going to plug this number in to either equation. Now let's go ahead and plug it into the bottom one, because why not? So we're going to do that. So we're replacing n with negative 3. So we still have 3m plus 5 times n, which is negative 3. And that equals negative 3. Now you see I used the original equation because that's what the step said, because it's the simplest form of it, so we don't have to deal with bigger numbers. So now we solve for m. So we have 3m actually minus 15 equals negative 3. Add 15 to both sides, so that 3m equals 12. Oops, it's not writing. Divide by 3. So that m equals 4. So we have two answers. We have m equals 4 and n equals negative 3. So that's your solution. So let's look at one where we're using substitution. Okay. Now here are your steps for substitution. First, solve for an easy variable. Now when I say easy, I mean something that is going to be so easy to solve for that you have one step, if at all possible. So if you look, we have an x, we have a 3y, we have a negative 2x, and we have a 4y. Now if you look, the only one that does not have a coefficient is this x right here. That is my easy variable. That is easy because I'm not going to have to divide by anything. So that means I'm not dealing with fractions. Okay? If you want to deal with fractions, go pick a harder number. Go pick a harder variable to deal with. I don't want to deal with fractions. And I know you probably don't want to either, so we're going to pick that one. We have x plus 3y equals 12. Now we're going to take this and we're going to solve for the easiest variable, which is the x. So we need to get rid of the 3y. Alright, we did step 1. Step 2, plug into other equation. That means we are taking this x and we are plugging it in right here to the other equation that we have. So if our equation is negative 2 times x, we're going to stick our x in to have negative 3y plus 12 plus 4y equals 9. So we just go from there, and we solve for y. So we have to distribute the negative 2 to get 6y minus 24 plus 4y equals 9. Now from here, remember, we're combining like terms before you do anything else, because we have a 4y and a 6y. That gives us a 10y minus 24 equals 9. Add 24 to both sides. Right, so we're solving for y. We get that equals 33. Divide by 10. And you can make it a decimal. We can make this a 3.3. Now once we have solved, that was step 3, we're going to do step 4. Plug it back into easy equation and solve. When I say easy equation, I mean the red equation. So we're taking this and plugging it in there. Okay, because you've already done work. You've already solved for x, so plug it in so that when you're solving for x again, it's already there. So for instance, we're going to have x equals negative 3 times y, which is 3.3 plus 12. Well, this is so much easier than plugging it into an original equation. You can, there's nothing wrong with it, but I want to go the easy route. So we're going to do this. We're going to have x equal to negative 9.9 plus 12, which gives us 2.1. So there are our answers. So that's it. We just solved one using elimination and then using substitution. Now I need to show you one more thing before we move on. I'm going to show you how to write something as a matrix. Now you've probably never heard about this before ever in your entire life, but that's fine. Okay, that's why I'm showing you how to write it as a matrix today. So you're going to write a system as a matrix. So we have our system from the example 1. 2m plus 4n equals negative 4, and 3m plus 5n equals negative 3. So we're going to write that as a matrix, and this is how you do it. You take your coefficients. What are coefficients? They're the numbers out front. Just the numbers, not the letters, just the numbers. And you're going to put it in a bracket, a very large bracket. So if we have 2m, the coefficient here is 2. If we have 3m on the bottom, the coefficient is 3. So I'm going to place it the way that I see it in the equation without my variables. So next to the 2, I have a 4n, so I have the 4. And then I have a 5n, so I have a 5. And they're just supposed to sit there next to each other. Now, instead of the equal sign, I'm going to draw a line. And then I'm going to put what's on the other side of the equal sign, which is pretty simple because those don't have variables, right? We have negative 4 and negative 3. That is a matrix. This will help us solve in the future. But we need to be able to set them up. So, now that we've done one, for example 1, let's go ahead and do it for example 2, just so you get a little bit of more experience with it. And I'm going to color code it for you this time. So, we have x plus 3y equals 12. And then we have negative 2x plus 4y equals 9. Okay, that's our system, right? And it's got this in front of it. And when we turn it into a matrix, we're going to have, for our x, right? X doesn't have a number out front, but you're not going to put the x. You're going to put the number that's imaginarily there, right? I'm assuming that that's a word. And it's going to be that 1, that implied 1. So we have a 1 here. And then the negative 2x has a negative 2. So a negative 2 goes there. Now onto the blue column. Well, the 3y, so we have a 3. And we have a 4y, so we have a 4. And then our line for the equal sign. And then our red column. So 12 and 9. So that's how you set up a matrix. That's it. So now you have seen elimination, substitution, and writing things as a matrix. Now because you have all of this experience now, I need you to try 2. That's it. That's all I'm asking. Use this video. Go back and watch it again. Watch it as many times as you need. to be able to solve these systems. Okay, you're doing the first one by elimination and the second one by substitution. And I need you to do those methods specifically. So follow the steps. They're right here. Right, you're following the steps. Those and these. Okay, it's outlined for you. Try them. Okay, I need to see these done when you come into class. Because when we come into class, we're doing even more with it. So it's important that you have this fundamental knowledge. Have a wonderful day.